Welcome to another video in my channel. So this is the setup. This is going to be a comparison between the two products, PZEM-061 and D69-2049. These are two high voltage power meters. They only work for AC, alternating current. And in this video I will show you which one you should buy, the differences, and basically how they work, and their wiring diagram, and everything else basically to put one of these in your home. Okay, so as you can see here, before we start, this is working with high voltage. Okay, this is live electricity here. If I turn this on, there's a switch here. It's gonna go in here, and this is not a toy, you know, like this wire, like there are wires here that are, you know, at a really high voltage. If you touch them, I mean, you're going to get shocked or killed possibly, and hopefully not killed, but well, just be careful with that. If you don't know what you're doing, in fact, you should watch some other videos, because I'm not going to explain what it's like to touch a live wire. But yeah, it's dangerous. Just keep that in mind. So make sure you have a little bit of basics of high voltage. Okay, so we have the high voltage coming in through here. Okay, let me just put this in. Let's see, what do we have here? Okay, we have the source. This is the source, and the electricity comes in through here into this power brick. It comes into here. Actually, there's a switch here. If I turn this on, the high voltage continues, and it will be down into these wires here. So, and then this is where it gets interesting. This wire can split into two or into three. In my case, into three, as I have ground here. Okay, this is the ground wire. Green and yellow. These are the colorings on it. There might be different in your country and the wire that you buy. So just be careful of that. This is the ground. Oops. And then we have the negative wire. Okay, that's negative right here. And then okay, so oops, well, this isn't okay, the negative, and then the negative passes into the other power brick with the ground wire. And then you also have the positive, and this is the most important one. This is the wire that comes out. It's usually red or dark brown or something like that, but it might be something else. So make sure you measure it with a voltage meter, or with I have something like this. Okay, this is very simple, and basically if you touch something, okay, for example, negative, I don't know if you can see that, negative is not showing anything. Okay, there is no electricity passing. But if you were to touch, if I was to touch, for example, in here, there's a connection here, there's a soldering joint. You can see that. You see that? High voltage. Again. So if I were to touch that, oh my goodness, I would have gotten shocked pretty good. So be careful with this. Make sure, you know, if you're playing around with this, check everything, double check, triple check. This is serious stuff. Okay, and then we have the ground wire. So ground wire, no electricity. Live wire here, electricity. Okay, high voltage. So be careful. Now in the ground wire there could be electricity, like in here. It's not showing up on the full scale, like there isn't a lot of volts like in this one. This one just goes right to the max, but this one has a little bit, and that That's normal. Well, it shouldn't be, but in some homes, I suppose, when the wiring's a little bit messed up, um, there's some electricity that can pass into the ground wire. Okay. I live in a really old building here, so the electricity kind of, you know, it can kind of jump a little bit. It doesn't mean that there is a lot of current here, a lot of electricity like in this one. This is the most dangerous one, of course, the positive. But you can actually measure it with a power meter. Actually, we can do that. This video will probably end up being a little bit longer than it should, but let's have a look. Okay, so this is the power meter here, and we can switch it to, let's say, 600 AC. Okay, we can leave it. Let's put that into here. We can put it up here. Well, that's not gonna work. Let's see. Kind of. Okay, good enough. A little bit of reflection there, but you can see it. All right, so we can actually measure this. We have the two leads. Okay, they're made out of plastic, so there's an insulatant. Like, you never want to touch this with your bare hand. You always want to. In fact, I recommend wearing gloves. I can't stress enough how I don't want anybody getting hurt playing with this. So okay, let's test it. So we have the negative and we have the positive. Okay, double check. This is on 600. You can see that. Okay, it's going to measure an alternating current, and this is the alternating symbol right here, okay, between 0 and 600. So depending on where you live, you'll get a different reading. As I'm in Europe right now, if I touch this should read 240, 241. Okay, high voltage. So yeah, this is what you can do, and then you can measure this. Why was there a voltage there? So I suppose we can change these around. We have, like, how many volts are passing through here, and really you can see on the power meter that even though this little tool was showing that there could be like high voltage, you can double check with a power meter and you'll be able to see that there's really, there's some jumping of electricity because electricity travels in waves, and there's some interference, so there's a little bit of jumping coming through the ground wire, but it's not really dangerous. Okay, in fact, there's no high voltage coming in here. Okay, so I just wanted to show you that. Let's move this away, put this back here. Okay. Next thing, okay, so we have the ground over here. We have the negative and the positive. And the interesting thing with this is that, this should look that before. Okay, so interesting thing is that this positive, for these power meters to work, one of the signal wires, either the negative or the positive, has to pass through these coils. Okay, and I recommend, I always put them on the positive wire. They will work on the negative, they will never work if you put both wires, or if you put the neutral. You're going to get an inaccurate reading or no reading at all. So I would recommend negative or positive, but definitely positive, because as the way that you wire electricity, usually if you wanted to connect a light bulb, you always want to, as in a switch, you always want to cut the power to the live wire, to the positive, not the negative. It's just a safer way of constructing and building your projects. So what happens is that the positive here, these coils, the positive wire has to pass through the coils. Okay, and that's how when it passes through, electricity travels in waves, in frequencies. So these coils, there's a bunch of windings here. They can pick up this frequency and they can send it to the, oops, well, let's put that here. They can send it to the power meter, the vibrations, the frequency that of the live wire, and then this voltmeter will be able to pick this up. Okay, so again, same thing for this one. The coil is on the live wire. Put both of them. It doesn't make a difference if you put both of them together like that. I thought maybe there would be some kind of inaccurate readings, but it doesn't seem to matter. They're quite accurate, and there is no big problems if you join them in like this or you put them too close. It shouldn't matter. So yeah, this one, the D69-2049, also same thing. And then out of these power meters, you need to power them somehow. Okay, so right now they are not being powered, they are disconnected. So they are measuring this coil, but there is no electricity to supply these to actually do the calculations and turn on the LCD. Okay, this is just a measuring coil. So you need another connection to AC current. Okay, these should be connected to AC, and I'll show you the wiring diagram in a bit, but I think you can see pretty much in here. I'll actually connect it on screen in just a minute. Okay, so let's put this away. So we have electricity coming into the load here. Okay, so if I turn this on, you see that? Now if I plug anything in here, these meters will be able to measure the voltage, the current, the power, and so on. But there's nothing plugged in, and also the meters aren't plugged in as well. Okay, but let's just put this in here. So this is going to be the load. Oops. This is going to be the load, and that's going to, you'll see it in the wiring diagram how this all works out. So we have the source. Should be very simple. I tried to make it as simple as I could. The source voltage comes in through here, turn it on, and then you have the load, and then in between you have to connect the positive. I would recommend the positive to the coils, or the coils, the positive wire has to pass through the coils, let's say. Okay. Okay, so now we're going to connect these. We're going to connect this one and this one to electricity. Now I can connect them two ways. Okay, I can connect them, for example, let's start with this one. Okay, let's do this one for now, and then I have the power meter. Okay, actually we're gonna turn this on for now and then turn this off for now. Okay, so there's no live electricity passing through here, and then it's just a wire that's coming out here through the little power brick. There is a red and a black wire here, but actually it doesn't matter. Okay, as this is alternating current, AC, positive and negative in this case, it doesn't matter. In fact, if you look on the back of this, there is no markings for positive or negative. Okay, so they can yeah, I'll show you a better picture of this after, but there's nothing else to show you that you can't mix this up. You can actually put the red wire into where the black wire is right now, and it will be fine. And the same thing goes for the coil. Okay, the same thing goes for the coil. And actually, as you can see here, the coil here, the wires are, both of them are green, so it doesn't matter. In fact, you can put both green wires in on this one as well, and yeah, because it doesn't make a difference in this case. Okay, so let's plug this in. We're gonna plug it into here. We're gonna move this away a little bit. So we're gonna plug it into here. Okay, now this power meter turns on, because there's power meter going into here, into this source. Where's my source? Okay, yeah. Okay, the source is actually up here. It comes in through here, and then as there's electricity here, this isn't on. There's no but as there's electricity here, this power meter is able to pick that up. Okay, it's now connected. So we have the volts. Yeah, as I said, depending on the country, it could be 110, 120. Here it's about 230 to 240, which this is fine. This is Spain, by the way. In Canada, it's 120, 110. In US, I guess it's similar. And then we have the amps. As you can see, there's nothing that's being used right now, so this is quite accurate. It zeroes out fine. There are 0 amps and 0 watts being used. Actually, what we can do here is pull up this let's see, where is that? Formulas. Okay, so we have I'll explain that in a bit, but we have basically power is watts, is calculated in watts. Okay, let's make this a little bit bigger. Power is calculated in watts, and it's basically volts times amps. Okay, so you can see here volts and amps. And why is the power 0? Because 235 volts times 0 amps, that's still 0 power. Okay, so nothing is being used, no electricity is being drawn. There's energy here, which is calculated watts times hours. Okay, how much energy has something has used over a time period, in this case hours. And that's because just it hasn't been reset yet. Okay, so I've been using this before, I've been trying it out, I've tested it just a few moments before, so that's why. But you can reset that, and I'll show you how to do that in a moment. So that's that. Let's put that down here. Okay, so nothing is coming in. The power reading is not reading anything, which is correct. Now, if we were to power this on, there's an LED in here. In fact, we can do this. We're gonna turn the power so it's passing through the coil, and then turn this LED on. So this LED, actually the power consumption of this is so small that it doesn't actually measure anything. Okay, it's this LED, it's like consuming milliamps, which is not even on the scale. I mean, it's up to 2 decimal points. But let's see if we plug in something into here. Bear with me. Let's plug in a phone charger. Okay, this is a Samsung phone charger. Let's plug this in. Okay. So the phone charger is not using anything right now, as actually there is nothing plugged in. Let's see, into the charger. Give me one moment. Okay, so if you connect a power bank to the charger, let's do that right now. So we have the power bank. We can connect this, and then we can connect one of these wires. Okay, like this. Power bank turns on. As you can see now, there is 1 watt of energy being used. Okay, this is actually at 100%. You can see that. Okay, so it's fully charged. Now, if it wasn't, this would have been drawing some ARPs. It would have been a little bit more, but it is using some power. Even this LED in here. So you can see that it detected a very little change. Okay, still not even 10 milliamps, I suppose, being drawn, but it has some reading. Maybe it's not showing up here, but it can detect the watts. So that's kind of interesting, because I would imagine there are some, if it's reading 0 here, there wouldn't be anything here. But I suppose there it can detect milliamps. It's just unable to show them on this display. So it's detecting something. That's a good sign. That means that it should be a fairly accurate readout, even with little things, plugging in like chargers and power banks. Okay. So you might be wondering, like, why isn't this using anything right now? Well, because there's nothing connected here. There's as the phone chargers on their own, they use very little or almost no, if no energy at all. In fact, they shouldn't be using any energy if there's nothing plugged in, just like a socket. So this is the reason. All right, so let's remove this. In fact, actually, what I want to do is I want to try another power bank. I don't actually have one that's just charged, but we're gonna try this. I'll take this. Okay, so this is another power bank. We're gonna plug this in, and this actually has a little USB power meter. So now, okay, this power bank is charging. It's at 100%. It's probably just topping up, but you can see that there's a USB power multimeter plugged in, and also this has some circuitry in it. So this is using up a little bit of power, and sorry guys, the video just crashed on me. So let's pick up back where we left off. We had the PZEM-061 power meter plugged into here. Okay, and that's measuring using this coil. It's measuring how much this charger and this power bank and this LCD display and this LED light, everything basically past the AC load. It's measuring everything that's being plugged into here. Okay, so right now it's measuring that it's using 0.03 of an amp. That's 30 milliamps, which is very, very little. This power bank is charged, and the LEDs themselves and the circuitry aren't using that much energy, right? And you can see that it's only, all of this is only consuming 3.6 watts. Well, that is something. That is it's actually quite a lot for something that's not being used that much. I mean, this is fully charged already, but as you can see, that stuff like this, when they're plugged in, they are using a little bit of energy, okay, a little bit of power, and that's what I wanted to show you with this. Now we can disconnect and plug in something else, but before we do, I want to show you something else. We're gonna plug in a few different things here just to show you how much energy and power they're using. And but before we do, I want to disconnect everything and rewire everything very quickly, just to show you, and also turn this guy on as well. So we're gonna turn this off. Actually, there's one more thing that I wanted to show you, because let's disconnect this. Oops, let's move this out of the way. The wiring of this, you might be wondering, why did I plug it in here? Can't I plug it in here? Well, yes, actually, in fact, it depends what you want to do. You can plug it in before or after, okay? The problem is that, well, it's actually a choice. It's not a problem. It depends what you want to do. Like right now, for example, this being off, you can measure whether it's on or off. Okay, the power meter, the LCD will stay on, and it will continuously measure everything here. Now, if we unplug this from here, okay, and we plug it into here. Okay, and then as you can see, if you plug it in right now, as it is right now, you can measure stuff as long as you can measure things. And actually, where I'm getting with this is that right now, as you can see, that you can measure if you plug it in behind the coil. Okay, you can actually connect this power meter at the source, or like before the coil or after the coil. Okay, now if you connect it past these coils, okay, down somewhere down here at the load section, you can actually measure the load of the meter itself and add it to the value. So as you can see here, that this meter being plugged in into the wall socket is consuming 1.2 watts. And so for the LCD and for the circuitry to work and for the measuring to happen, it's consuming some energy. And you can actually measure this in and add it into the value. Okay, so it's yeah, it's quite interesting, and it depends what you want to do. If you want to exclude the measurements of you know, if you want, you know, that this power meter is constantly using 1.2 watts, you can disconnect it from here and you can plug it into here, which will not record the readings of the consumption of the power meter itself. And that's what I wanted to show you. Okay, so it depends what you want to do. I would plug them in. Usually I think it's a good idea to just plug them in so they're measuring themselves, but it's really up to you. Okay, so now okay, let's turn this off. And then I'm gonna show you what I did here. Okay, let's move this a little bit. Okay, so let's unplug this. So the electricity is off. Make sure you double check that. So this is off. There's no electricity coming in here. So I can show you, okay, what I did. I actually split these wires open so I can demonstrate that. And so these are banana plugs, okay, and this is one way that you can do this, okay. And these banana plugs connect together. They're basically, that's how the wires are connected, and that's how I was able to put these coils onto the live wire. Okay, so these are the coils, quite similar, maybe they're even the same, some color differences, different companies, but yeah, that's how it works. So the live wire has to pass through the inside of this coil. So that's how you can do this. You can do it with a banana plug. You just have to split the wire open and take it and put the coil through. So we're gonna put this back in. We're gonna put this one back in. We're gonna connect it. Okay. Let's rearrange the setup here. This was here, more or less. Move this up a little bit. Okay, so now they're back. Yeah, that's one way. Okay, actually I don't like that. Let's reverse this so this wire goes out. Well, and this one as well. Just doesn't really matter. Okay, I just put it back how it was. Okay, so this one here, just for the sake of visualizing this. Okay, and then yeah, that's basically it. Doesn't matter where they are on the wire. Okay, they can be here, you can put them anywhere. Basically, it didn't make a difference in tests I've done. Okay, so just keep that in mind. Now what we're gonna do is we're going to plug in both of these. Okay, and I'm actually going to plug in, well, I'm gonna plug in this one. Well, I have a little problem here, so it doesn't, we're gonna plug these in so they're not going to be measuring themselves. Actually, let me see, I can't make up my mind on this, sorry about that. Okay, let's plug this in, because I need 1 second here. So let's plug these in like that. We're gonna disconnect this, and we're going to disconnect this, and we're going to put this in like this, and then we're going to put this in like this. So now I have space to connect. Oops. Well, this one's gonna go like this into here, and then this one is for the black one. For this one here, this one is going to also go in here. So the voltmeters, they won't be measuring themselves because I actually have I want to hook them up the same way. Okay, so these can go up here. Okay, so here we go. Okay, so now whatever I plug in here is going to be measured by both of these at the same time. Okay, and we can actually see, we can do that right now. Let's turn this on. Power is going in. LED on, but nothing plugged into the load yet. Okay, so let's bring in something something more interesting then. Let's see, for example, I don't know if we can fit into the picture. Okay, let's move this. Okay, so what it is, it's a fan. Okay, it's a little small fan, and well, this fan, you can't really see it, but I'll read it out to you. It says here that it can use up to 20 watts potency, the energy 20 watts. Okay, okay, so let's plug in this guy. Let's put it into here. Let's put that around, and then we're gonna plug it into here. Okay, now the switch for this fan is on the back here. Okay, you can see it in this camera. So if I hit the switch, power turns on, the fan turns on. Okay, so now the fan is running, and you can see it that it's consuming 11.5 watt, well, 11 watts. As you can see, they're both almost exactly the same. 11.5, 11.5. Okay, so fairly accurate. Let's see, where's my pointer here? Okay, so okay, so as you can see, fairly accurate. 231 volts, 231 volts. This one has a higher resolution. Okay, now where's my pen? So as you can see here, this one is 231 point something. Okay, so this one is a higher resolution. It's showing an extra digit here, which that's not to say that this one doesn't, because it was measuring some watts, whereas when the amperage was at 0, which means it's possible that this one is just, is able to measure it, it's just not showing it. Okay, for high voltage, the little point volts maybe which are not as important, but for amps they are. But as you can see here, this has a little bit of extra resolution that it is able to show you an extra decimal point right here, which I think is great. And let's look at the layout. So we have watts being shown at the top here in yellow, and then we have amps in green down here, 0.7 of an amp, and here it's about the same, 0.7. This one's showing 0.8. Again, this could be a very small difference. Okay, in fact, there shouldn't be any difference if I move these around. As you can see, the coils, if I move them, nothing is really changing here. So there's no interference. It just could be like a small roundup difference between these two. But as the watts are accurate, I'm pretty confident that this is working fine. So on this one, you also have the kilowatts, okay, the kilowatts used. And just like here, okay, watt hours, kilowatt hours. This one is just because I had it plugged in. The number is so large, it actually changed to kilowatt hours, which when I reset it in a bit, you'll be able to see it, that this is showing kilowatts, which is actually just because the number is so large, eventually when it, instead of rolling over, it changes to kilowatts from watt hours. Okay. Okay, well, I'll show you when I reset it how this works. Let's put that away. So there you have both of these meters. You have the plan, the fan is running, and it's using a little bit of energy. Now, this fan has two modes. One is like light blowing mode, and then you have, well, actually I suppose this is the one that's like lighter. So this one is like, this one is only using 5.8 watts. 5.8 watts. Amps are the same, as you can see here. Okay, so this is 5.8 watts, and then when we turn on the other mode, that's using about 11 amps. Okay, so even though the specs on the back of this, they say 20 watts, the maximum it's using is 11, and that's fine, because you know, sometimes in terms of electricity, you always sometimes at the beginning when you turn this on, it uses a little bit more. There could be some kind of a surge current that goes above this rating. So let's have a look. Well, in this case, it didn't do that, but just keep that in mind. Okay, so that's fine. So we have the fan, and we know that the fan is using 11 or 5 amps depending. So let's put that away. Let's unplug this, and we can actually have a little bit of fun here. Just plug in something like this, okay, a light bulb, and we can measure this very quickly. Yeah, I just put a little bit of hot glue and safety tape here so it doesn't, as this cord is kind of short. So we're gonna plug this in. Let's turn this off for now and plug this in. We're gonna put it in like this. Okay, I suppose yeah, that's one way that you can do it. Okay, so as soon as I flip the switch, this light bulb will turn on, and actually it's going to probably blind the camera a little bit, but let's see. Okay, and we can see that this light bulb is consuming very little, 2.8 amps, and on this one 2.7, 2.7, yeah. So yeah, these LED light bulbs, the very little ones, they're quite energy saving almost. It's just like a power bank fully charged being plugged in or something like that. Okay, so it's they're quite efficient. Let's turn this off. Okay, so 2.7 amps, and if we plug in something else, another one, let's see, do I have another one that we can show you? No, not really. Okay, so we're gonna plug in this one, and this one should be a beast. It should really consume a lot of energy, and give out a lot of brightness. So okay, let's put that up here. Okay, all right, let's turn this on, and it should really, this one should really be maybe even too bright, and it should, maybe it's probably going to blind the camera for a bit. Okay, yeah, well, this one is really bright. You can't even, it's going to be difficult to read this, but as you can see, this one, it's showing that it's consuming 115 watts. Okay, wow, what a difference between the other one. And then on this one as well, 113.7, 113 watts. So 115, 113, a small difference, a very small difference. And that could be because of the resolution on this is a little bit higher. I'm not sure, but yeah, there's a small difference, but not that much. Fairly accurate, I would say. 114 amps, watts, and then 112 watts on this one. So quite interesting. Big big energy use on some of these light bulbs. Okay, so there's something to keep in mind. I'm gonna unplug this. This actually gets hot, quite hot, quite quick, and I'm not going to touch that. That's probably kind of hot, but yeah, keep that in mind. The light bulbs that you buy, they make a big difference in the amount of energy that you use at home. Okay, so here we go. So yeah, that's what I wanted to show you. Basically, both of these are quite nice. Actually, what we can do is show you them with the lights off. Okay, so I can't really turn everything off, but I can reduce some light. Okay, most of it is good enough. So at night, that's how they look. That's quite nice. Okay. And actually, you can turn the LED on this one off. You can't turn it off on this one, I don't think. I haven't found a way. But on this one, it's actually, well, the background is nice because it's black, so just the digits are showing up. It's not going to light up a room. But this LED can actually be turned off by just short pressing the button here. And actually, we're going to play around with the buttons, with the functions, because both of these have the little buttons here, and I'll show you what you can do with that. Just have to find something, for example, okay, pencil. So we're gonna reset this. We're actually gonna do, if you, there's couple of ways to do this. You can short press it, so like this, okay, and short pressing just basically turns the LED on and off, which is nice. Now if you hold it, okay, hold it, you can actually there's something here that's, it's quite interesting. You can actually set like kind of like an alarm. So what happens is that this is right now the one here that's set at 1000 watts, okay, 1 kilowatts, one 1000 watts, okay. The K here stands for 1000, okay, so just like 1000, 1K resistor, 1000 watts. So that's what it is. So it's like kind of like an alarm feature or function for this. So if the load happens to pass, whatever the load from here happens to be over 1000 watts, this LCD will actually start flashing on and off to give you like an alarm, and it can be reset by pressing this button. Okay, well, so you can change these. You can set it at a higher resolution. I suppose I can show you this. So this is at 1. When the number is flashing, you can actually change it. Okay, so let's leave that at 0. Let's put that at 0. Let's 0 that. Okay, and then let's change that to like a really small value, to 1. So okay, and then once you set that, you have to hold the button here, pass. Okay, So now the alarm is kind of set. So if I plug in something in here and it passes that value, it's going to start flashing. So let's have a look. We can plug in something, for example, so unplug this. Let's plug this in. Okay, this is power adapter for an HP laptop. As you can see, as soon as I plug this in, this started flashing because it passed over 100 watts of energy that we set here. So this is the alarm, basically. This is the alarm feature, and that's how it works. Okay. And it's I suppose, okay, it stopped flashing because the load is off, and it's the energy has returned to normal. So whenever you get like an overvoltage, a certain amount of watts, this will start flashing. Okay, see, which is quite useful. If you have this at home, you can actually if you don't want to go over a certain voltage, you can set this and it's going to give you a little notification. Okay, now if you can stop this from flashing by just single clicking, but then as the alarm is set, and this has memory, it remembers that as soon as the voltage goes over, it should start flashing actually. Let's see. Well, I suppose I turn off the alarm, but if I were to turn this off, okay, and turn this back on, you see the alarm is back on. But you can actually cancel the alarm or turn off the alarm temporarily until you replug this with a switch. Okay, so the next thing that we're gonna do is actually we're going to reset the reading on the watt hours here. Okay, so to do that, you press the button again, and this time you hold it, and you hold it even longer, and then this is flashing, and well, I suppose I missed my opportunity to change that. Okay, we're gonna do it again. Okay, so now as soon as this is flashing, you hit that to 0, and that's it. Okay, and the energy has been reset. So now whatever you plug in here, this number is going to change. It's going to go up again, and it's going to start measuring from 0. Okay, so that's an interesting feature. That's that. Okay, now we're gonna do the same for this one. We're gonna play around with this button here. I actually don't remember. So let's hold this down. So short clicking it doesn't do anything. Okay, but let's hold it down. Okay, so just the only option here is basically resetting it. By holding it for a really long time, you reset the kilowatt hours. And yeah, so that's what it is. You cannot turn the LCD on and off, which is fine because I really like the contrast. The black background really works nice. Yeah, so that's there you have it. Another thing that I can show you, I suppose, is, let's do a little bit of a zoom here. Let's move these out. Okay, let's zoom in and see everything a little bit up close, with maybe a better video quality for these. Okay, so just give me a moment, bear with me. I'm gonna use my phone camera to zoom in on these, and here we go. All right, so there's the wiring, the ground, and the negative. Okay, they're plugged in using banana plugs, and they're the coils with the live wire. Okay, so you can see probably should give you a better perspective with a little bit more zoom. Okay, so this is coming into here, the power meter. You can have a look. As you can see, one of them is a little bit bigger. Okay, so this one, the black one, that one's a little bit bigger, and this one's smaller. So consider that when you're building your projects. Let's have a look at the LCD zoomed in. Okay, it's actually on this phone, it's not showing up that the contrast is quite, let's see if we can fix that. Can actually take a photo here. Okay, so the contrast is actually better than what it looks on the camera here. Actually, if we zoom out, you can see that it's fine. And then let's have a look at this one. A little bit of glare. Yeah, that's one thing, but actually this glare doesn't really matter. It's just the phone and the light. Depends how you look at it, from which angle, I suppose. Yeah, so this one looks really, really nice. Zoom in. Okay. One thing that I wanted to see, with this phone actually plugged in like this, how do they look like at night? So let's hit the lights. And not too bad. There's one light coming in through here. Let's turn this off. Actually, yeah, they look quite nice. Even on there's a little bit of light coming in through the other room, but yeah. Let's try to focus on this a little bit. So, and there you have it. Okay, let's turn the lights back on. This one and this one. All right. Okay, so the last thing that I wanted to show you is the schematic here. Let's have a look. Okay, the wiring diagram, the schematic, and as you can see, they look different, but actually the wiring is the same. They're just they have been drawn a little bit differently. But yeah, in case you're wondering, the load. Let's bring up this pencil here. The load, as you can see, this is the load, and the coil here, CT, which is the coil, and the load. And you know that one of the wires, doesn't matter which one, the positive or the negative, has to go through the coil. Okay, as you can see, there are no markings for positive and negative. It's alternating current. So one of the wires has to pass through the coil for the measurement to happen. But other than that, everything is the same. Okay. So that's that. Okay, let's take these out. Okay, one thing I actually wanted to show you, just in case you're wondering, like, if I put this through the negative wire, what would happen, and what would happen if I put these through ground. This video is really taking a long time, but might as well make it complete, right? So let's turn these off. Let's turn this off. I'm actually gonna unplug that. Okay, we don't need that. And plug both of these into here. Okay, let's move these out of the way, make some room. Okay, and this can be reversed. Okay, here we go. So let's space these out a little bit. Okay, so we can actually unplug this, and let's put them through, for example, the ground wire. So here's the coil. It's gonna go through here, and this one, Actually, let's do one through the ground wire, one through the live wire. Okay, I'm just curious. There shouldn't be any differences in measurements, but what do you know? For the sake of science, let's have a look. Okay, so we have space these out. We have the positive. Okay, these they rearranged, so we're gonna take these out. Positive, negative, and ground. Source is still the same. Let's take out the ground. Okay, but as you can see, here we have the positive. One of them is going to go, this one is going to go through the positive lead. This one is going to go through the negative lead. And the ground will remain the ground. We'll just connect to the load here. Okay, so let's have a look. Let's move this a little bit, and everything is fine here. Okay, let's turn this on. Power is passing through here. Let's turn this on. And yeah, as you can see that the power meters are measuring themselves now. But it doesn't matter. Yeah, you can see that 1.9, or let's round it up, 2 watts, they're about the same. Okay, there's a small difference here. I have a feeling that because of the volts, the higher resolution on the volts, this has a little bit more accuracy, whereas this one kind of has to round it up. So it's rounding it up, and it's creating a little bit more of a voltage difference. Okay, it's not going to matter that much, but this one is a little bit more accurate. Okay, with high voltages, I think these are not going to make a big difference, to be fair. But as you can see that, yeah, it doesn't matter if you connect it to either the positive or ground, they will work exactly the same, no difference. If you connect this through both of them, in fact, yeah, that's another experiment. Okay, this is off. Check everything. We can unplug this, and I'm gonna show you what happens if you, for example, if you run these through, for example, through the negative and positive. Okay, well, this one doesn't fit. They have to go one at a time. Okay, so negative and positive. Let's see if I can do this safely. Positive and negative. So this one's going through, both wires are going through this one, and then this one, we're gonna connect it on ground. Just well, just for the sake of experiment, let's say. So this one on the ground. Whoa, this one a little bit of yeah, like a, well, nothing. Okay, I might be thinking it's coming from somewhere. A little bit of electricity in this one. Sometimes it can jump as you play around with this, but not significant. This is the ground wire. It's just the wiring in this building, and yeah, in this flat is a little bit shady, let's say, something that I have to fix. But yeah, you have this one on the ground, and you have the positive and negative. And in fact, what should happen, what I suspect will happen, that these will not show anything as soon as I turn this on. Okay, everything is wired up fine. We can turn this on. We can turn this on, and I suspect nothing will show up here. No measurements being shown. As you can see, 0. Let's move this here because of the glare. So you can see 0 watts and 0 watts. Okay, so it doesn't work when you connect these, just through this wire. If you were to connect the coil through this, it's not gonna work, because the positive and the negative, the frequencies, they will cancel each other out. This is alternating current. So so you're not going to get any reading if you do this. And of course, on the ground, that's another, there's no electricity passing through here, so it's not reading anything. So I just wanted to show you that. Okay, let's turn this off. Let's turn this off, and basically, yeah, that's yeah, let's arrange it into okay, so everything's off. Let's put it back how it was very quickly. The way that it should be wired. So imagine you have to rewire it again. Positive. You can put the other coil if you want for both meters. That's it. Reconnect it. Negative and the ground. Okay, and yeah, as I told you, sometimes you won't get a ground. You will only have the positive and the negative, which is fine. If you have the ground reconnected, because you know it's a safety feature. Okay, so that's it for that. Actually, wanted to talk a little bit more about this. I wanted to show you actually, as you might be wondering, like, you know, how much do these cost and are they expensive? Actually, these are the ones that I bought, and as you can see, this one, they're about $12 American dollars. That's 11 euros, more or less. They should be around that price, between 10 to $15 American dollars. I would say that's a good range to go for. Actually, what happened with if you get someone like a buyer that doesn't have a lot of sold items, like what happened here was, actually I wanted this one, the one in the picture, and the one that I got, this is actually a different model, but actually what happened was that I think they got mixed up and they sent me the other one, the one that's in the video, which so just be careful with that. If the prices, read everything, read the descriptions. In fact, yeah, so be careful with that. But these are quite cheap. In fact, this one, I think, for 12 euros is a bargain. That was a great buy. So keep that in mind. Yeah, and thanks for watching. Thanks for watching this video. I hope you enjoyed it. And if you did, subscribe to my channel. I'll definitely be making more videos. And if you like this, kind of stuff, it's interesting and you learned something, this really helps out. Yeah, if you subscribe, I'll probably keep these videos coming.